I want a tank. That's good. I'm going to build a tank, but this is more like an RC car with treads. Why treads, you might be asking? Well, there's actually a really easy answer. They're awesome! I am going to be developing all the mechanical components and electronics from scratch. I'm starting with the drivetrain because it's pretty useless to design electronics for a motor that's not attached to anything. Some preliminary research showed that a brushed DC motor should probably suffice in the situation. Because we're building our own control circuitry, it's good to have it simple. They just take a voltage from 0 to whatever, and that's how fast they spin. Pretty easy. I started by designing some treads. I figured this is probably the most important part of the build, so I wanted to get this right. I went through a ton of iterating on this design. For the treads, I decided to try and use an experimental material. This is polycarbonate, or PC. It prints at a really high temperature and generally likes to warp, but it has some amazing impact strength. I decided to use this material because I needed dimensional stability. After repeated force loading and unloading on the pivot points of the tracks, the holes can get deformed. Polycarbonate prevents that because it's very rigid. PC also lets me reduce weight in parts while keeping them strong and having good tensile strength for pulling the track. I also annealed the parts for strength. This just means heating them up and letting them cool down. I had to make a bunch of different versions of the track, and because of that, I ended up producing way too many of these. Now that I have the track sorted, I could work on the suspension. I picked out some random RC shocks on Amazon. These are what I'm going to use to provide dampening on the suspension system. I have two different springs inside of these shocks. One of them is a weak spring and the other one is a very strong spring. This is the weak one. If I push it just enough to where it starts moving, we get about 300 grams of force. And then as I push more, it applies more of that force to the scale. Whereas if I take the heavy shock, if I push until it just starts moving, we're already applying like 800 grams. And now it's moving and I'm applying much more force. So it's a lot harder to compress this one, which we need because if you look at the diagram, we're essentially pushing a lever where we have a mechanical disadvantage. After some failed suspension tests, I figured out that I needed to support the suspension from both sides. When I used only one panel, I found that it would bow outward, which the tracks did not like very much. The suspension geometry is also very finicky. It has to be the exact correct length for the tracks, otherwise they'll be far too slack or too tight. Nice little Thomas the Tank Engine thing in the back. That is scary, Jesus. Well, that sucked. Right now, this thing can barely even propel itself, and there's a couple reasons for that. First and foremost, the power supply. This thing can only do 10 amps, which has nowhere near enough torque when applied to the motor. The second thing is control circuitry. I have to physically change the voltage on the power supply. This is awful and will not work on a remote controlled vehicle. This is an H-bridge. It lets me drive a motor forward and backwards and control the speed with a microcontroller. It's how I've been controlling the motor in these test setups. I broke a whole bunch of these before I realized my power supply was causing problems. This leads back to the first problem. My power supply is too weak and it also has reverse protection. In the final build, I'll be using LiPo batteries, so I might as well start using them now. These are smaller than the ones I'm going to end up using, but they're still better than my power supply. That 35C means that they can supply around 40 amps. Along with supplying a lot more current, these batteries have another advantage. They can be charged. When you stop driving a motor, it'll keep spinning because it has inertia. That spinning turns the motor into a generator with what's called back EMF. Because my power supply has reverse protection, it just goes into destroying my electronics. The batteries fix this automatically. Instead of destroying stuff, the electricity is spent charging the batteries back up, which also serves to extend the battery life. Alright, enough electronics. Let's make it out of metal. Now I just gotta find some aluminum. Let me go visit my aluminum patch. Oh, my extrusion. That's still a little underground. Let's check on the plate. Yeah, there it is. Ooh. Nice. Now that all the geometry's in place, I can black it out. There's one more problem I have to solve. The tracks right now are very slippery and they don't grip the floor at all, especially not snow. To fix that, I've put screw holes in the tracks so that I can screw down some treads. I've made these out of TPU so they can absorb vibrations and deform to the terrain. Oh yeah, did I mention I had to make 2 of them? So now I'm done with the side modules. There's still a bunch of work to do, like I still have to make the entire chassis and all the electronics, which I'm working with the team on. But still, I can't help but feel like I'm missing something. Of course, I have to test it.
If that was a little underwhelming, it's because I only ran them at 30% power. The reason I did that is because every time I turn these on, I feel like I'm in mortal peril.
Have you ever seen a lipo explode?
Once I get a solid base, I'll be able to fully power them, which should be coming up in the next video. Thanks for watching. See you later.